Hello guys, and welcome back to Khaliltronics. In today's video we are going to see a special types of differentiation known as implicit. So in this video we are going to start with explanation and then solving problems. So actually implicit differentiation is a method of finding the derivatives of what dy dx. So if the system of the equation is given, like x squared plus y squared is equal to, let's say, 200. So it's just to find dy by what dx from this given what system of the equation. So what you need to do is to just look carefully and then differentiate both what x component and then y component, and then the constant terms component. So we're gonna start from basics. So let's take this question. We have x squared plus y squared is equal to 25. So we are given this system of the equation to find what dy by dx, that's derivative. So what we need to do is to firstly we can multiply through by what d by dx. So after multiplication through by ddx, so we can say d by dx of x squared then plus d by dx of what y square of y square, and then is equal to d by dx of 25 of what 25. Okay, yeah, of 25. So you have to differentiate x squared with respect to x, so it's just normal differentiation. We can say we have 2x, and then plus we have to differentiate x squared with respect to what x, that's derivative of x squared. So there's no way we can differentiate x squared with respect to x, because it's not what equal function. So we can say we can differentiate y squared and then add its derivative. So we can say we differential of y square, let's say we have y square, so to differentiate this we can say 2y as well. So we can say we have a 2y as normal differentiation, then we will add what it is derivative, that's dy by dx, and then is equal to derivative of constant term, remember is 0, so we can have this 2x plus 2y dy by dx, and then it's equals to 0. So to make x dy by dx to be subject, we can say minus 2x is equal to 2y dy dx. So from here we can make dy dx to be subject by dividing both sides by the coefficient of it, which is 2y. So we can say minus 2x by 2y is equal to what dy dx. So from here we get dy dx as what which is equal to, we can also say minus x by y by 2 goes 2. So from here we get dy dx to be equal to negative x by y. So this is the procedure, so no need to wasting your time doing such this. All you need to do, if you have x components, if you have x, no need to do just some these steps. So if you have x component, you just differentiate it. If you have y component, you just take the derivative of it and then multiply by it is by dy dx. So you remember our answer is just to x by y, so you can simply say derivative of this is what, since this x component is just normal differentiation, we can say 2x, and then plus derivative of this, we can say it is what, 2y, and then add no derivative, that's dy dx, and then derivative of constant is 0. So from here to find the dy dx, we can make dy dx to be subject, then we can say dy dx is equal to this one to be shifted into right hand side, which is negative 2x, then divided by the coefficient of dy dx, which is what, 2y. So from here we can 2 goes to 2, which is what, minus x over y. So basically this is how you should solve it. If you have the if it's normal x component, you just take its derivative. Yeah, just take its derivatives. So if it is y component, you just take the derivatives of y and then add dy dx to it, and then derivative of constant is 0. So this is how it should be. So let's take some questions and see how it is work. So without wasting time, we're gonna take another questions. So we have another questions as x square plus 2xy plus y square is equal to 5. So the question is given as to find dy dx, that's dy dx is to find this. So what we need to do is to just follow the same procedure that we did before. So the derivative of this is what, 2x, and then derivative of this, so as you see here is 2xy, which is also here is what, multiplication between x and y, which is product rule. So we just take one to be constant and then differentiate the other one, take the other one constant and then differentiate the other part. So let's say we take this to be one part, and then this is for the other types. Let's say this, we call it for the other part. So from here, let me change pen. So derivative of x square, we have 2x, and then plus we'll take 2x to be constant, so we can say 2x to be constants. So the derivative of y is what, 1, and then add dy dx since it is y, and then plus take 1 to be constant, so here y is constant, and then derivative of this is what, derivative of 2x is just what, 2, then plus, remember if you are differentiating x, it's just normal differentiation. If you are to differentiate y, you can differentiate y and then add dy dx. So that's what we did. We add what, we make 2x to be constant, that's we make it equal to constant, and then derivative of y is what, 1, and then we add dy dx, and then for the other part we make y to be constant, so we leave it as a constant, and then derivative of 2x is what, is just 2. So then for this one, a derivative of y we can say is what, 2y. So since it is y, we will add what, dy dx, then is equal to what, derivative of constant is what, 0. So from here we need to get dy dx by making it to be subject. So we join this together, this one and this one together, and 2x and 2y to the other side. So we can say we have what, 2x dy dx plus 2y dy dx is equal to minus 2x plus it's also negative, that's minus 2x minus 2y. So from where we will factor out dy dx. So we have dy dx into what, we have 2x plus the other part we have 2y, then is equivalent to what, minus 2 into what x plus what y by factorizing the two. So we'll divide both sides by to get dy dx, we will divide through by what 2x plus what 2y here by what 2x plus what 2y. So this go with this, so we'll have dy by dx to be equal to minus 2 into what x plus y all over. Here we'll factor out 2, we have 2 into x plus y. So x plus y goes x plus y, will have minus 2 by 2, which is equal to negative 1. So let's take another question. So another question, we have example 3, we have 5xy plus y cube is equal to what 20. So for this question, this is another differentiation using product rule, since it's multiplication between x and y. So we'll keep 5x to be one part. Let's see here, all this 5x to be one part and the y to be other part, this y to be other part. So we'll say keep one constant. The first one is what 5x, the second one is what y. So keep 5x to be constant, so we say 5x is constant, and then differentiate the other one. So the derivative of y, single y, is just 1, since 1 is the coefficient of y. So we'll say 1, and then since we are differentiating y, we would add dy dx, and then take another part. So we are taking y to be constant and then differentiate the other one. So at this part we are differentiating x, which is we are differentiating 5x, and derivative of 5x is just 5. So derivative of 5x is just what 5. Then is equal to derivative of constant term, which is 20, is the derivative of constant 20 is just 0. So from here we'll make dy by dx to be subject. We'll have 5x dy by dx plus what 5y, we have right here, we have y cube. The derivative of this is equal to 3y square. Since we are differentiating y, we will add dy dx. So dy dx is equal to derivative of 20 is just 0. So we can say we have what 5y plus what 3 y square dy dx. So we have to make what dy dx to be subject by merging the two, this one and this one, and make this one in the other side. So we'll have dy by dx into, we have 5x here, which is 5x, and then plus we have this 3y square, and then for the other side, if we shift this to the right hand side, we will have negative 5y. Then from here we can say dy dx is equal to, by dividing both sides through the coefficient of dy dx, we will have minus 5y all over 5x plus what 3y squared. So this is the final answer for this question. We'll move to another question. Another question is given as to find the derivative of this, which is, another set of question is given as to find, let's see, we have root x square, we have root of s cube y, we have root s cube y minus what x square is equal to what 16. So we have to find what dy dx. So this is simple. We are to just firstly we are to square both sides. We are to square both sides. So if you square the equation through both sides, the root goes square. So we'll have x cubed y minus x squared is equal to what? 16 times what? 16. So we have to get dy dx. This is product rule also. So we can say take this one constant, differentiate the other part. We have x cubed as a y cubed as a constant. We have to differentiate y. The derivative of y is just 1, and then we add dy dx, and then take this one constant, which is y, and then differentiate the other part is what? 3. Differential of y cubed is what? 3x squared. So since we are differentiating x, no need to add dy dx, and then minus the differential of derivative of x squared is just what? 2x, and then derivative of constant term 16 times 16 is another constant. Derivative of it is what? 0. So from here we can make dy to be subject. We can say we have what? x cubed dy dx, then plus we have 3x squared multiplied by y minus 2x is equal to what? 0. So from here we can shift this to right hand side, which is what? Negative 2 become positive 2 x, then minus 3x squared y, which here we have x cubed dy dx. So to get dy dx, we have to divide through by the coefficient of this, which is x squared, x cubed I mean. Sorry, here is x cubed, so here to divide by x cubed, here also by x cubed. So this goes with this. We have dy by dx is equal to what? Yeah, if you like you can factor out x. We have x out into 2 minus 3xy by what? X cubed. We can say x times x squared. This go with this, so we'll have dx to be equal to what? Dy dx to be equal to 2 minus 3xy by what? X squared. So let's take another questions, which is last questions for this differentiation by implicit differentiation. So the last question is given as to find derivative of this, that's cos x squared plus sine here is y squared square is equal to what? 600. So to find this is you have to use the differentiation by chain rule. You have to just take derivative of this, and then you have to get derivative of this, and then leave this whatever inside, leave it alone, leave inside alone, and then find derivative of whatever inside. So firstly, we are trying to get dy dx as our what on m. So we would say the derivative of course we know it what? Negative sign. Yes, so we leave inside alone, so we have x squared at inside, and then we are to what? Find derivative of whatever inside the bracket, the parenthesis. So we say derivative of x squared is what? 2x. And then for the other part, we know that derivative of sine is what? Cos, and we leave the whatever inside alone, so we have y squared, and then derivative of y squared is what? 2y, and then since we are differentiating y, we will say we will add what? Dy by dx, and then derivative of constant term, we remember, is 0. So from here we can see we have minus 2x sine what? x square, and then plus 2y cos what y square dy by what dx. So from here we have to make dy dx to be subject, then we can shift this one to the other side, then we'll have 2y cos what 2y cos y square, yes, y, dy dx is equal to what 2x, yes, 2x sine what x square. So to get dy dx, we will divide through we will divide both sides by the coefficient of dy dx. So we see 2y what cos y square, and then here 2y cos y square. So this goes this actually, so we have dy dx is equal to what 2x sine of x square, and then by 2y cos y square. So this is the answer. So I think with this you will be able to find any given system, to find derivative of any given equations, to find dy dx. So this is how you should get differentiation using implicit. So don't forget to subscribe, give a like and comment, and also click on bell icon. So it's me, Electronics. See you in the next video. Thank you.